Good afternoon, respected judges and fellow friends in the SOFE SEAR level competition. My name is Arun and I'm from Singapore Institute of Technology in collaboration with University of Glasgow. And today, my engineering topic that I'd like to share is Project RoboFarm. Without further ado, let's proceed with the presentation. So, the agenda for my presentation today would include a self-introduction of myself, the purpose of RoboFarm, the idea inspirations that led to the development of RoboFarm, the functions of RoboFarm, and finally, the impacts of RoboFarm worldwide. So, just a bit of myself. I graduated from Singapore Polytechnic in 2019, whereby then went to do national service in Singapore as mandatory for all guys. And some of my interests would include loving the nature as well as loving traveling. So, firstly, the purpose of RoboFarm and what it aims to achieve. Let's move on into this segment. What exactly is RoboFarm? Now, RoboFarm is an octocopter that aims to revolutionize farming on an advanced level. So, what exactly an octocopter is basically a UAV or a drone with 8 leading branches to its respective propellers. Drones nowadays, usually the basic drone just has is mainly called a quadcopter, which only has 4 propellers. And the key features of RoboFarm that I'd like to highlight is basically planting of seeds over a large field space, maintaining pest control by spraying disinfectants on crops, and maximizing the use of sustainable energy via solar panels. Now, this is the main point that I'd like to draw your attention to, because unlike any other drones or UAVs, this product is not going to run on batteries, but purely solar energy. So, some idea inspirations that led to the development of RoboFarm. In this slide, you can see 3 exhibits, and I would like to run through with you all each and every exhibit, its pros and cons. Before running through its pros and cons, I'd like to say that, as you can see from in this slide, Exhibit 3 is already one existing product that is very similar to a quadcopter that I'm developing, which is called RoboFarm. So therefore, what I would like to achieve via this project is basically adding improvements to this product or this type of existing products that helps in the farming industry, which I'll be highlighting over the next few slides in this presentation. Without further ado, let's examine each exhibit. So firstly, in Exhibit 1, it's basically a ground farming device, streamlined body design, which helps increase mobility. However, it's only suitable for large-scale farming and unsuitable for confined spaces in a field, which makes it a huge disadvantage. Exhibit 2, very environment friendly because the use of solar energy is there on the top surfaces of the product. And the usage, as you can see, there's a drone that's flying at the behind of the product and probably helping in watering. However, the cons of this product is that plowing can't be done. Like for example, when a farmer has to plant seeds, the land has to be plowed properly, and then the seeds can be planted. So maybe what I can think is, because it's a ground-based product, maybe plowing technology can be embedded at the bottom surface area of the product so as to have smooth plowing of land, and that would be a greater advantage. Now, I would like to draw your attention to Exhibit 3, which is the most similar design that will be related to RoboFarm. So, as you can see, there are some nozzles that's popping out at all the base handles, like the stands, and this is actually a water spraying technology that's embedded in the product itself. After doing some research, these type of products actually consist of these nozzles to help spray disinfectants along like a field space to avoid pests, which is a brilliant idea that I like to include in my project. However, the cons of this product is that seeds can't be planted via this product because this product only aims to achieve to spray disinfectants, but would not help in planting of seeds around the land space. So after seeing the 3 exhibits, now I'd like to explain to you all about my product. Before that, I'd like to highlight one factor that as I want to achieve the planting of seeds via RoboFarm, I like to say that there are two processes of planting of seeds. One is via direct seeding and one is transplanting. Just a brief description of definitions of these two terms. Direct seeding, it's when like seeds can be just planted along a larger field space by just dropping seeds after proper plowing of land and suitable soil conditions. However, transplanting can only be done mainly by the humans, because the seeds have to undergo proper germination and mini development in a separate enclosed space before it can be planted on the ground itself. So seeds undergo germination between 2 to 4 weeks, and then these underdeveloped plants will then be manually distributed across the fields by farmers for further growth. Therefore, RoboFarm only aims to be beneficial for seeds that can be planted that's usually done via direct seeding. As you can see, carrots, radish, beans, and spinach. However, some of the crops that you can see on the other hand that's done via transplanting is kale, collards, and etc. So a basic step-by-step process of how dispersion of seeds is done via RoboFarm. These are the steps I would like to talk through. Firstly, we'll load the compartment with the correct amount of seeds so as to not exceed the allowable weight before flight. I will highlight more about the compartment in the next few slides. Nextly, a drone waypoint GPS navigation technology is induced in the system where the operator can control the movement of the octocopter by just a touch on a mobile device or tablet. This is nothing new as for those who have a brief idea of how DJI, the company that manufactures drones, work. This is the exact system that I like to embed in my project as well. Thirdly, as the octocopter makes its way to the user's desired location, the seeds will be dropped simultaneously during the flight. This is when the seeds in the compartment that we loaded, there's an open gate system that is present in the compartment through the software Arduino, which I'm also currently learning in my degree. And I like to embed this skill in this product. This will help control the opening of gates as the drone moves to its desired location. And once the percentage of seats in the compartment decreases, a notification or signal is sent via the app to the user's whatever phone, tablet, or whatever touchscreen device, and the user will then have to make his way to the home base, where the octocopter will automatically make its way for refueling purposes. So this is when, because just by a certain amount of seeds, we can't expect that certain amount of seeds to be dispersed over the field just within one run. Therefore, refilling is crucial in this process, and this is how refilling is done in this project. Okay, so like I said, some existing products. One of them is DJI's Grass MG1, and I would like to just loop this video so you guys can get a better idea. Just the loading is taking some time. Yeah. So as you can see in the video, one awesome example that's existing, DJI's Grass MG1. Basically, this product is, sorry, 1 second. Yeah. Sorry for the inconvenience caused. Yeah. So I'll just talk through as I run through this video. Keep it to. Yeah. Sorry for the inconvenience caused as it's loading. Yes, but this is one major product that I like to highlight, because the DJI's Grass MG1 is very similar to RoboFarm that I would like to develop, which is basically having the ease of spraying disinfectants over a large field space. And what I would like to add is the dispersion of seed technology in this product, which I'll be covering in the next few slides. Okay, in this slides, I would like to highlight about the sketches and the designs that I had before actually considering on making a suitable compartment that can be attached to the base of my product. So firstly, I would like to talk about the solar panels that will be embedded on the surface of the octocopter. I decide to add 25 solar panels of 20 cm by 20 cm of length and breadth on the top surface of the octocopter. So this is the primary source of energy that will be absorbed from the sun, converting to the electrical energy of the propellers, and then to the kinetic energy of the octocopter. So you got one of the questions that I got asked myself was that how exactly will this energy conversion happen? Which is why the eight different leading branches attached to the octocopter will have wirings that will be embedded internally, which will be connected to the solar panels that helps drives the octocopter. And nextly, the compartment that I decided will be attached to the base of the octocopter will be able to hold a certain amount of seeds that aid in the dispersion. So my first design that I thought would be beneficial for this compartment is a rectangular shaped detachable compartment. However, I decided to make some modifications, which I'll be sharing in the next slide. Yep, so first design improvement, the compartment design. As I have researched properly on the internet, I feel that a rectangular compartment in fact poses danger to the user as well as the product itself. And some of these limitations include immense stress building due to the sharp edges, and the sharp edges indeed leading to cuts and injuries, which will be experienced by the user. Now, this is really concerning, is because I would not want to make this very dangerous to the user, as it's important. And therefore, I decide to come up with a circular based compartment, which will be more catering to the user, as well as able to hold a greater quantity of seeds. So the curved edges will definitely not pose a danger of cuts or injuries to the user. And the detachable and the seed dispersion technology is way more enhanced. As you can see, at the bottom of the compartment, there are 16 through holes that will be able to disperse the seeds as the octocopter moves along the field space. Yeah, so this is why I decided to change from rectangular shape to a circular base compartment. And this is just like a slide assembly I made via SolidWorks on this compartment. Yeah, as you can see. So as you can see, the big cylinder on the top would be the compartment that will be attached. This part will be attached to the base of the octocopter, and then this is as you can see, this small cylinder in between the big and the small cylinder. This long one is used to connect the big cylinder to the extreme base, and this is a hollow figure to drop the seeds. And finally, as you can see, the most bottom product, which consists the holes, that is the product that will help disperse the seeds along the field. So now you guys will be asking me, I'm talking so much, and how would this be beneficial if I'm making a product that's similar to what companies like DJI has made and other companies? Why do you think RoboFarm would be the next revolution of farming? That's why I would like to highlight about the energy savings and other important related information in this series of slides. So I went to do a research and I found a similar case study that's related to my project. And I feel that this is very important in my project, because if I'm going to further develop this idea, I need to include these factors. So one formula that I saw would be how solar power and the power weight ratio is very related. So as you can see the graphs on the left, you'll see some certain plots. And my main takeaway from this study is the direct relationship between the solar power and the power weight ratio. Based on the formula, as you can see in this slide, where you can see that as the solar power, as the power weight ratio increases, the solar power generated by the solar panels increases, thus contributing to a greater hover time in the air. Now, this is very important because as I would like to develop a product that is able to run on on greater durations, I feel that this helps me. This is the factor that helped me derive the proper amount of solar panels that I would need for my product, which I've explained in the previous slides, 25 solar panels. And one of the achievements this project has achieved is that they achieved an outdoor time or air time over 3 hours 48 times longer than it can just last on one lithium battery on a quadcopter. So they have used a quadcopter in their case study, and my plan is not even to last 3 hours 48 minutes or longer. Even a minimum of 2 hours is sufficient for dispersion of seeds over a specified land space. So therefore, I believe that solar energy has the due power to achieve these kind of results. And apart from this, I realized that if this case study highlights the importance of power weight ratio, I have to pick a material that helps consume the least energy possible, as well as achieve the best hover time. Therefore, upon much consideration, I've decided to choose the carbon fiber reinforced with polymers as my main body due to its overwhelming purposes. This is because I compared different materials that will be a good choice for me to make my octocopter. For example, aluminium reinforced polymers, carbon fiber, even steel. And I feel that CFRP is one of the major and mainly used materials in the world right now, and I would like to embed it on my project as well. And finally, I would like to talk about the impact of RoboFarm in the future. So I would say that there are many other reasons why RoboFarm should be practiced in the future years, but these three sums up the main idea that I'm looking for. Firstly, human efforts should be minimized. Humans cannot be working every time for the next coming years and many years. And I feel that with this product, multiple problems can be solved, multiple activities can be done, and this would definitely lead to minimizing human efforts. Next, the power of aerial technology is something else. Aerial technology is used in many industries currently, and I want to really execute this product in the farming industry, because farming has its own advancements. However, with the power of seeding, direct seeding done aerially, it will definitely reduce human efforts, and this process can be fast. The planting of seeds can be maximized. And the main factor, conservation of energy via solar panels. Solar energy it's one main source of energy that humans can use to achieve many activities. And I feel that solar energy is super important in my project, as it helps to conserve human energy resources, especially like eliminate the use of batteries in drones. And I feel that this is going to be a huge asset to the farming industry, because as sunlight as sunlight is crucial for plants, why not it be crucial for my octocopter to grow healthy plants? I'd like to end off my presentation with this quote from Mahatma Gandhi: "Be the change you wish to see in the world." I feel that as young engineers and as students, it's important to come up with very creative ideas, and it's important for us to even highlight these ideas to the higher ups, get their inputs. And I feel that this quote really inspired me to to see a change in the farming industry, and therefore I decided to venture on how it can really improve the lives of farmers. And with that, I would like to thank all of you for listening to my presentation. And here's the question and answer segment. Thank you, judges, and thank you, friends. Thank you.